Hi everyone, so today what we're doing is we're moving into the implementation stage of the design unit, and we're thinking about how we move on from the design stages that we've done and finishing off with the query designs we looked at last day, and how we move that into SQL that we can actually manipulate and use databases with. Now, you've actually done the most difficult part of this because you've come up with the query design. So taking what the customer actually wants and changing that into query designs is the hardest part. And all you're doing now is changing those query designs into physical SQL code, which can be implemented into your databases. Now, it's important to remember that SQL code, just like Visual Basic or Python or any other type of code you're going to come across, HTML, for example, it follows a strict set of rules and criteria in layout. So you just need to make sure that you follow the grammatical rules of the code in order to get your queries written out correctly. So the appendix that I've attached to this week's work is appendix number 11. Now, one thing I wanted to point out is at the top here, there should be 4 tables. The one that's here seems to have snuck behind this one, but because it's in a PDF format, I can't seem to bring it out. I do have a Word document where you can see all 4, but the coding in the Word document is based on Access coding rather than SQL, pure SQL coding, and I really don't want to confuse you by giving you a different document. So we're just going to stick with this one. It's not really important because you've got all 4 of these databases listed already in various other appendixes, and you know what they are. And below you've got a list of all of the attribute names just here, and the wee sample database showing you what type of information you're going to have inside there. Okay, now one thing I want to point out first of all, just before we get started, is there is a big difference between Access and SQL coding, and I want to apologise for the work that you were sent out last week. The appendix that I walked through in the tutorial and the appendix that I covered in the video are both pure SQL coding, where the wildcards were a percentage sign if you're using more than one random symbol, or an underscore if you're using one random symbol. So you remember that from like the Mac question, or looking for second names where the second letter was H, for example. In Access, and I think in the questions that you were set, those 2 symbols changed to a question mark and a star. Okay, so some of you, when you answered your questions, you did it based on the example that you're given. That's absolutely fine. It's no problem. It would work if you're using it in Microsoft Access, but for the purpose of what we are doing and focusing on SQL only, I want you to stick to using an underscore for one random character, a percentage sign for a number of random characters, and the star sign only when you want to select all of the fields within a database. And all of the examples that you should look at from now should be consistent in the layout, only SQL. But just in case you see those other examples, then you'll know why they're there and why they were slightly different from the video that I attached. Okay, second thing I want to point out is this little note here, which is really important, because when this database has been set up, this name of this attribute has been called customer hash with a symbol rather than customer num or number or no. Then what we'll need to do every time we refer to this attribute is put it inside square brackets, just so the computer doesn't think that the hashtag is part of something else or is treating it like a specialised symbol. With every other field will be absolutely fine because they're just generic text, but with the customer star or the customer number field, we'll need to make sure we put that in square brackets. And that is the case in all of the examples you're going to look at, just to point that out to you ahead of time. Okay, so here's some information in your wildcards that's telling you what they are. These are the 2 that we're going to be using in SQL, as I've just mentioned. Underneath it tells you what the equivalent ones are in Access. So if you've used them in your homework from last week, then you'll know what they are relating to and what they should be. And we're going to try and stick to the SQL ones. It gives you some lovely examples underneath of where they can be used for, so you can see what type of things they'll do. Okay. So basically what this appendix is linked to the last appendix you looked at. So appendix 10, I think it was called, which was based on query designs, had 12 different queries and how they were broken down into designs. And this appendix has 12 different SQL statements which are based on those query designs. So I'll attach last week's appendix as well, just to make sure you have both of them to refer to help you with your work. So you should be able to see the layout and connection between the first example in Appendix 10 and the first example here in Appendix 11, and they should relate to the same query. This part here, for example, will be the same query description, so that you can see how the SQL is linked. Okay. Now, the next thing I want to point out that you'll notice the biggest difference between the query designs and the SQL itself. So select is obviously the keyword that replaces the fields and queries that you're looking, the attributes you're looking for. So that's where these things are just listed normally as the exact same name, so that's not a problem. From replaces the tables and queries where you're looking for the information from. So we're looking for information from the hotel and the resort entities. Where is your criteria that you were looking for, okay? And the biggest thing you'll notice in here that's not listed in the query designs is the links between your tables, okay? So if you are linking between the hotel and the resort table, you've got two tables here, you need to create a foreign to primary key link, okay? Now, when we are linking, you'll notice that also, because we're linking the same attribute, resort ID, from both tables, whenever we refer to resort ID, even if it's up here, we need to make sure we link it to one of the tables. So we're saying that resort ID in the hotel table or entity should be equal to the resort ID in the resort entity. And where those two things are equal to each other, and the resort name is like, starts with an A character, and the resort type is coastal, then display the hotel name, the swimming pool, the resort name, and the resort type. Okay, so that's what that does. The reason that we only need one connection in there is that we've got two tables. Okay, if we had 3 tables, we would need 2 connections. If we had 4 tables, we would need 3 connections. Okay, it's entirely up to you how you lay your SQL statements out, but they have to start with a select and they have to end with a semicolon. Okay, I like to have them select from where, and I would actually have this and on a new line, so it's easy to see each criteria you're looking at. It would be where, this part, and this part, new line, and this part. But it's entirely up to you. Some people like to stick to the select where from, and these match up nicely with your headings from your table in your query designs. Okay, let's go down and have a look at different ones. This one's slightly more complex. You can see we've got 4 tables, so we're going to need 3 connections, foreign keys to primary keys, to show the connection between these tables. Okay, so we're starting off with what we're selecting. There's all the fields that we selected. From, we've listed all 4 of our tables. Where, now we can see connection number 1 is from the customer table to the booking table, and those two are connected by a customer number, customer hash, which I mentioned earlier on, because it has a symbol, needs to go inside square brackets. Okay, so if those two are equal to each other, and bookings, hotel reference is equal to hotels, hotel reference, and hotel's resort number is equal to resort's resort number, and the surname has got H as a second letter, then we're going to display all of this information. At the bottom, it's just giving you information about how we order it. Your order is your sorting. Okay, so order by surname in ascending order, and then start date in ascending order, finishing off with our semicolon. There's nothing more complex than this one. As the first example, it's just that we're linking 4 tables, so we need to have 3 of these primary key to foreign key links listed in. Now, it will always be the same thing. So every time you want to link customer to the booking table, you'll always link it by customer number, because that is the primary to foreign key link that you created right back when you did the entity relationship diagram for this one. Okay, and again, hotel reference is the primary key to foreign key between hotel and booking, so that's the same one, and resort ID will always link hotel and resort. So you just need to make sure that you remember where the primary keys are. But if you have a look at right back at the beginning, which is why these have been provided, you can see what the primary and foreign keys are and how they link to each other. So here, booking number is a primary key, foreign key and hotel reference are both foreign keys, sorry, customer number and hotel reference are foreign keys from the other tables. Okay, so you should have all that information from your previous work. So most of them go on to show you different examples. If I go up a little bit more, examples of where you can see that working, right? And then it starts talking about your calculations. So the next thing we want to talk about in your calculations is how we actually lay them out, because they're pretty similar but a little bit different to how we lay them out in our query designs. In the query designs, we would give them a readable heading first, we would put equals, and then we would write our calculation in. In SQL, we do it the opposite way around, so we put the calculation first and then we put a readable heading afterwards. Okay, these are how the calculations are written out. Again, very similar to what they were in our query design. So AVG is average, count is counting how many meet the criteria, max finds the highest, min finds the lowest, and sum is totaling up all of the numbers that are being looked at. Okay, if we go down and have a little example, so here we've got min price being found, maximum price being found from the product table. There's no need to put any where foreign key equal primary keys because we've only got one table, so that's nice and easy. These have not been given readable headings, which is why they're just laid out nice and simply. The function goes first, and whatever you're going to do with the function goes inside. Okay, so there's some simple examples. If we go down to example 3, where it's looking for the minimum price per night and the maximum price per night, it's given it a readable heading. We have to apply the readable heading instead of with an equal sign, with an as, and then our heading goes inside square brackets because it contains spaces. Okay, so much like when the customer hash needed to go inside square brackets because it had a symbol, this one has to go inside square brackets because it has spaces. Okay, so we've got cheapest price per night, and then the other one is the dearest price per night. Probably should have a wee space in there. Okay, so the other way around, this would have been displayed the other way around in your query design. It would have said cheapest price per night equals min price per night. So you have to flip them round and then square brackets round the heading. Okay, another example that isn't mentioned earlier on here in example 4 is rounding. So where we've got an average being worked out, an average number of nights, what the round function does, very similar to math.round from Visual Basic, it says that whatever this answer comes out as, round it to 2 decimal places. And that's quite useful if you want to round something to 0 decimal places. Maybe you're trying to work out the number of people or something, you want that to be a round number, you can round to 0 number of places. So that's basically a function with another function inside it. Again, there should be examples of this in any ones where it wants you to use it. Okay, we go down, we've still got our star wildcard when we want to say count all, so that says count all. That's still okay to use in SQL. Again, here's another one, so sum up the number of party as instead of the equals before, and then people on holiday in July has to go in square brackets because it is got spaces in it. Okay, so I think that's all of the information that you need. So to give you a rundown of the most important things, number 1, you need to make sure that you're using the correct wildcards. SQL wildcards more important than access ones. So underscore, percentage sign, star when you want to use all of the attributes. Important step number 2, you need square brackets around anything that's got spaces or fancy symbols, names of attributes or names of your calculations that you're doing. Important step number 3, under all of the where clauses, if you have more than one table, you need to make sure that you are linking your tables together using the primary foreign key link. Okay. Step number 4, important step, if you are referring to an attribute that is in 2 of the tables that you are looking at, you need to make sure that you are referring to the attribute with the entity in front of it, regardless of where it comes in the SQL statement. So even if you're displaying the product ID up here in the select statement, you still need to write either product.product.id or order.product.id. Okay? And the last point is making sure that you get your calculation names the right way round. So you want the name after the calculation rather than before. Okay, and hopefully that'll help. I'll attach all that document so you can have a read through it. And the question sheet you're going to get this week is based on your queries from last week. So you'll get all the answers to last week's work. And then you've got to write your SQL code just in here. Okay, hopefully that'll make sense. We'll go over it if it needs to be on the tutorial next session. And you can let me know if you've got any issues. Okay, speak to you later, guys. Bye.